Hello, my name's John Dobson and I'd like to introduce you to our ECIO range of single board microcontrollers. There are three products in the ECIO range which you can see here. We have two products based on PIC Micro 18 series devices, a small 28-pin one, a 40-pin one, and we also have an ECIO based on an Atmel ARM ARM7 device. The boards themselves are mounted in such a way so that the connectors are 0.6 inches wide, which is the standard width of the larger dual inline type sockets, and that means they can be plugged into conventional DIL sockets in your own circuit boards or into prototype boards like the one you can see here. So just to show you how these work, what I can do is first of all put an ECIO into a prototype board. Then what I'm going to do is wire a small circuit that we can program using Flowcode. So on this circuit I'm going to have a single switch and a single LED, and I'm going to write a program that just mirrors the input from the switch and mirrors that input to the output on the LED. So the first thing I've got to do is connect a power and ground wire. Then what I'm going to do is take the positive or power signal, put it into the switch, and then feed that signal into input C0 on the microcontroller. And we're going to have a small resistor going down to ground from the input C0 to get rid of any residual charge. Then what I'm going to do is take the ground wire, I'm going to connect that to the cathode of an LED, and then the output of A0 I'm going to feed to the anode of the LED. And what I'm using here is just a small protostation board, just because it's got some neat input and output devices already wired into it. Now, what I'm going to do then is just simply connect the ECIO using USB to the computer. Now, the great thing about ECIOs is once you've put it into your prototype board or your device, it's all ready to use. The ECIOs themselves have a small onboard crystal, so you don't need to worry about clocking the device. They've also got a reset pin, and there's a jumper here, and you can select the power to come from either the USB lead, which is what I've got on this particular system, or you can set the power to come from an external device. Now, if you build one of these into your own board, the great thing about that is on the ECIOs there's a bootloader, and this means that it's got everything you need to actually program the device. You don't need any other programming hardware. So, to show you how that works, what I've got here in Flowcode is a very simple program. I've got an input switch on bit C0, an output LED on A0. The program has a begin, a loop, and the loop is while one, so it cycles around there forever. And what it does is takes an input from port C. We're using the entire port, we could just use one bit, but it's easier, and it's putting that input into a variable called input. It's then taking that variable, the input variable, and it's reflecting that onto port A. So it's a very simple circuit, and you can see if I simulate it here, when I press the switch with the mouse, the LED lights up, and when I release it, it goes off. Now, there's no setup or configuration to be done because I've selected an ECIO as a device I'm using, so Flowcode understands all the parameters with regards to programming, clocking, and so on. So we just click on the send button, and now it says connect the ECIO. To connect the ECIO, I just press the reset button, the LED flashes on it, the computer recognizes that the ECIO is plugged in, the code is sent down, and now you can see that on our hardware, when I press the switch, the input to C0 goes high, and that is reflected to the output on the LED. So hopefully you can see that these ECIOs are incredibly simple and easy to use. There's no setup, no fuss with programming or anything like that, and there's a range of devices. You can start with the small 28-pin device, which costs around £12 or around 15 euros, and as your project needs to progress, you can go up to the 40-pin one. And if you want something that's really, really fast to use with floating point mathematics and lots of other features, you can move up to the ARM one we've got here. Okay, that concludes this presentation. Thank you for watching.